With circles, it's real important that we know the standard form of a circle formula. That's x minus h squared plus y minus k squared is equal to r squared, where hk is the center of my circle and r is the radius. That's all we need to even graph it. First example that we're going to look at, we're actually being asked to graph the equation of a circle. So all we're going to have to do is look at the standard form, pull the information out, and just graph. In this particular example, our center is 3, negative 2. Don't forget, when you pull the h and k out of the standard form of the formula, you actually use the opposite sign. So the h would be a positive 3 because it appears as minus 3 in the formula. The k would be a negative 2 because it appears as a positive 2 in the formula. In the radius, let's see, that's r squared, so the square root of that would be 3. Let's graph it. The point 3, negative 2 is located there. In order to graph the equation of the circle now, I look at the radius. It's telling me I need to go 3 units in every direction. So I go 3 units up, 3 units down, 3 to the left, and 3 to the right. And then all you have to do is connect the points. The second type of problem you may run across with circles is writing the standard form. So if they give you the equation as x squared plus y squared plus 8x plus 4y plus 16 is equal to 0, and you're asked to write it in standard form so that we can identify the center and radius, all you have to do is start by grouping the x's together. X squared plus 8x, leave a little bit of room, plus, in the second parentheses, y squared plus 4y. Group the y terms together, and again, leave a little bit of room. I'm going to go ahead and move the constant term over to the other side. That'll become a negative 16. Now we get to borrow from our friend completing the square. And just a little bit. We're going to take half the middle term coefficient here. It's 8. Half of a positive 8 is a positive 4. So we're going to take a positive 4, square it, and add it to both sides. We're going to do the same thing with the y terms. We're going to take this half the middle term coefficient, which is 4. Half of positive 4 is positive 2 squared. Add it to both sides. Now here's where we get to borrow again from our friend completing the square. This whole trinomial that we built by taking half the middle term coefficient and adding the square to both sides, we borrowed so that we were able to write the perfect square as what is being squared in this position, an x, and what is being squared in that position, a positive 4. We can do the same thing with the trinomial we built in the y terms. What's being squared in this first position? A y. And what is being squared in that last position? A positive 2. And the constants is just a matter of term of getting your calculator out there. Negative 16 plus 4 squared, that's 16, that's 0, plus 2 squared, a total of 4. Now we've written our standard form, and if we have to identify the center, it's a negative 4, negative 2, with a radius of 2.